Today we are breaking down an A-Level Chemistry enthalpy change question using Q equals mcΔT. First, enthalpy change is the energy transferred during a reaction. We use the sign of delta H to describe whether heat is released or absorbed. Point 1. In an exothermic reaction, energy moves to the surroundings. The products are lower than the reactants, so delta H is negative. Point 2. In an endothermic reaction, energy is taken in from the surroundings. The products are higher, so delta H is positive. Point 3. The vertical gap between reactants and products is the enthalpy change. Remember, lower products mean exothermic, and higher products mean endothermic. Next, we calculate the energy transferred using Q equals mcΔT. The temperature change links the experiment to the energy calculation. Point 1. Q is the energy transferred, measured in joules. Write the formula before substituting any values. Point 2. M is the mass of the solution in grams. Keep the mass and the specific heat capacity in compatible units. Point 3. C delta T combines the specific heat capacity with the temperature change. Keep the units consistent, then apply the correct sign. Finally, Hess cycles compare different energy routes. The total enthalpy change is the same for the same start and end states. Point 1. Start with the substances in the same initial state. This fixes the beginning of the cycle. Point 2. Follow a route through known reactions and their enthalpy changes. Add the values along the route you choose. Point 3. Check that the arrows and signs add to the target delta H. Enthalpy is a state function, so the route can change, but the overall value cannot. Q3BII, the key idea is heat energy transferred to water. When you see mass, temperature change, and 4.18, use Q equals mcΔT. The mass of water is 200 grams, and the temperature rises from 18.5 to 37.5 degrees Celsius. So delta T is 19.0 degrees. Then Q equals 200 times 4.18 times 19.0, which gives 15,884 joules. Now Q3BIV uses that energy to find the enthalpy change of combustion. This time, the answer must be in kilojoules per mole. First, convert 15,884 joules into 15.884 kilojoules. Then calculate the moles of thiophene burned. For C4H4S, the molar mass is 84.1 grams per mole. Moles equals 0.63 divided by 84.1, which is 0.00749 moles. Then 15.884 divided by 0.00749 gives about 2120 kilojoules per mole. Because combustion releases energy, the sign is negative. For the final question, use the enthalpy of formation data in the table. First, write the formation equations, then calculate the enthalpy change for the reaction. The reaction enthalpy is the formation enthalpy of the products minus the formation enthalpy of the reactants. Substituting the values gives minus 24.8 kilojoules per mole. Build a mechanism step by step. Use the same four-step check every time. First, identify the electrophile. Look for the electron pore center. The first rule is simple. Start at an electron pair. Point the arrow towards an electron pore atom or bond. Finally, check charges, bonds, and the leaving group. The pattern is identify, point, draw, then check. Keep practicing with real exam questions on EduNinja. Topic by topic practice. Step-by-step solutions. Smart paper builder. Revision notes and more.